Okay, we just finished the build of the board. This board, we got everything on it, and now we can choose the edge, the shape our Blastic Scale will have, and you have two choices. Because with the flashing the same hardware before calibration, you can go with the Pro version with an old board here in this build, but the substance of the Pro version is that you can have it like an independent system and it's portable. And you have also, this is the main component. It is a load cell and it can take even 300 kilos and it remains really sensible, and can take grams. This is a lot of nice feature in itself. I'm just like resetting it, and I can show you that it goes like in milligrams also, although I think it's preset with centigrams. That means you can like a weight, like a little bunch of caps, like 5 bottle caps. You can just starting to weight little weights like that and going up with the bigger ones. Or, but it's a little bit more expensive, even if it works with the same thing. So we have this other version that is like a more fixed solution for a workspace, and it is an hack from the Blastic Scale. I've chosen a wooden one because it's less plastic, and you have to go with the one with the 4 sensors. And when you just pull this up, you have the first time you have just to click it away. You can access the wiring and the cells themselves, and there is a wonderful guide online to modify this one that is from SparkFun, and I'm linking. I think I can show you the link also in the video. You have to desolder the wire. Originally they are here, and I've got that on video. I can maybe cut and show you the images. Originally they were all wired here, and I've got the separated wires from the individual sensor, and we're going to do this way this time. I have a separated guide to go build the Pro, and this kind of scale is very economic. You can go down under 40 euros for an IoT scale that commercially available. They start from 500 and up, going to 2000 and more. So it's a very convenient way, and we have to make this build that really puts value in this project, and I hope it will make it more likely to spread. And to do the build, we start just like that, putting this up, soldering the wires. When we are at this stage, we label the wire with upper right, upper left, down right, down left, and which with every of this group of wires we have to find the sensor one that is labeled C on the old method here, and to do that we will use the multimeter, going with the resistance on the 200 scale in the continuous mode, and we have to find the wire that has the least. We will check the wires 2 by 2. We start with the black and yellow, and putting the probes here. I don't know if you can read this. Hopefully yes, if I have not got some reflection. Okay, yellow and black from the upper right, they go Hope I can find. If I'm not able to reach the wire, I will strip them a little bit. Also, I do that because I'm going to insert in the Mammoth, and if you have not the stripping machine, you can do that by with the scissor, but it will be, you will need more care because you need to be careful not to cut the actual wire, that they are thin wires. Okay, we have exposed sufficient copper of the wire, and so I'm going like that, and I'm finding some reading from resistance here. Hopefully it's not showing anything. This is working or not. Let me check this out. Okay, I was choosing the wrong selection on the wheel here. I have to go with the resistance, the home symbol, of course, and I'm choosing the 2000 sensibility and getting around 1K of resistance. I'm looking for the pair of cables that has the half the resistance of the other pair, so I'm choosing now red and black from the upper right cables. I have to strip also the red one. Then let's go with this check, and this checking 2000K. So I know now that the yellow one is the one that has the half the resistance of the other two combined, and is the sensor 1. And these ones, the yellow ones from the upper right, upper left, down right, are the ones that will go into this combinator here. This one takes all the yellow cables, but I will reach this location organizing the cables with this Mammoth placed on the scale, screwed to it, and then I will make a connection wire with this Ethernet, cut Ethernet cable. And okay, this is a correction of the build that is indeed quite simple, simpler than it was in the previous version. That was wrong also. This piece is not needed, it can go. You won't need to solder this strange style and difficult. And also the cable will also be only a 4-wire cable, and we are not using the previous cable which was an Ethernet one because it breaks here. You will need to do best and solder these screw terminals the other way with the wire feed on the outside, because it will be easier. And the main changes are in the combination of the wires from the 4 sensors into one big load sensor configured in the whetstone style that you can find in the SparkFun guide for the load sensor and the load sensor combinator. And so the key is to catalogate and nominate the 4 sensor for their position, and work upon that denomination. So upper left, upper right, lower down left, down right, they will become a special arrangement in which the central so-called wire, that is the sensor wire, you can find it by using the voltmeter, the multimeter, and finding the right wire, which is the one with the least resistance combination between the other two, as shown in the other video. In this case, it is the yellow wire, and that yellow wire will become the wire that connects to the board through a long cable, color coded as on the board. That is green, white, black, and red. And it is also written on the seal screen, and so it can be easy to manage this part. When you have coded in this way this sensor cable, you already are using the upper left, upper right, down left, down right configuration. So the upper left will be the black wire, the upper right will be the white wire, the down left will be the green wire, and down right will be the red wire. And I'm naming it UL, UR, DL, DR. And starting from this catalogation, I will link the other wires, and I'm planning to do it on another Mammoth. And so I'm taking the upper left and the down right red wire. It doesn't matter if you choose black or red, but you have to once you have chosen, you follow that configuration, not to mess up all the thing you are building here. So I decided that the red is the plus for me, so you have a reference also to the SparkFun guide. And I'm wiring the plus from the UL upper left with the plus of the down right. Once I've done that, I have to wire together to connect the upper right with the down left, and I'm doing that now, just in a moment. And after this is done, I will be linking accordingly in the right sequence that I will be also showing you on screen with the schematic. The minus cable, which I have arbitrarily decided it is the black one in my color coded from the color codes on my scale. It could be different from yours, because maybe the black or the red one, it can be the signal cable. In my case, it is the yellow one. So you will have to do the check with the multimeter first, and you, in that case, you won't be able to follow the same color coding I am following. The important thing is the relative connection of the wires. We are going to see the physical wiring, but you can help, and I just recommend to do that. You can help yourself with the schematics on screen, and also linked in the description below. I'm freeing these cables from the previously wrong configuration. Now I have took the extremes upper left and down right. The down right is the red cable. Yes. Now I have to join the black wire from the down right to the white. The white one is the upper right, and so down right, the upper right of the left, or the of the black of the minus will go together. This one is the down right, and this one is the upper right. Of course, the other two cables remaining blacks will go together. And with this, This apparently difficult color-coded wiring, it is ended, and it's in the physical reality is quite simple. You just have to choose the right wires, and then I will show you how to make a much more cleaner outlook and wiring here after I have linked everything. Now I'm jointing the upper left, upper right and the down right, giving that some boldness. And now I want to fix this connection. I'm using just one side of the Mammut, the other side is not used, but I like to reuse the material because they sold me a 12 strip, and so I could take advantage of it. And you can also have an 8 strip and cut half by half, and or even not cut it, but I like it because it's more in my opinion it's more manageable. Okay, this cable broke. I'm doing that again. I will accelerate it on your screen. Stripping again. It was worn out a little bit. You have just already seen that these cables are quite fragile, and because they are cheap and need special care. Of course, if you are mounting and dismantling the pieces, the components, you face this kind of effect, but it's not a huge problem, especially because this style has simplified the build and made it even less difficult and even less stressful for the cables. So I think it is a good advantage, beside the fact that this one works and the other one don't. And okay, you have to look when you're inserting the cables, because that's the key to the success in pinching them with the screw or not. And this is a little trick. Otherwise you have to repeat a lot of times the screwing down of these little thin cables. We're going with the upper left and down left, joining them. Maybe this will hold, I don't know. Let's check that. And like so. After I have finished connecting everything, I would like to give it a try, because I'm ready with the board and the powering also, so I want to check this out, and then I will cover everything if it works. Okay, I'm putting again the shield, so-called juxtaposed board on the Arduino, and I'm powering the Arduino with the same USB-C connector from my phone. This is a convenient way to power your scale, and let's check if it works. Crossing fingers. The board is starting up. It's already loaded with the let's check this if it works or not. Currently I think not working. Currently not working, and so we'll check again the thing, but okay, we are gonna resolve the wiring for the combination of the plus and minus cables from the spark fan combinator load sensor from household scale to make a load sensor in the whetstone configuration. That is the same that is used in this load sensor that we use to build a portable Blastic Scale. Now we are going to build the cheaper version with the same hardware and software, taking advantage of the possibility of combination these sensors. Un attimo, Nina. Then the trick of the thing is referring to the schematic, and the schematic it says that upper left, upper right, down left, down right are upper left black wire, and this is the black wire, and the upper left sensor just goes there. Upper right is the white one, down left is the green, and down right is the red. So we can see from the schematic board that the red wire goes with the green. So red and green are down right and down left. So we are taking the black of these and putting them together, which we made wrong in the previous attempt, that we are solving with this change. So down right and down left. So down right and down left, which are red and green. The remaining two, which are white and black. White and black are upper left is the black one, upper right is the white. They go together, of course. They were the remaining wires, but we are checking this because it will be useful to the next step when we will be connecting the arbitrarily chosen plus cables, which I allocated on the red wires. Okay, now we are done. And so the black goes with the green. Black and green. Black and green from the plus cable, which is red in our case. Black and green are upper left and down left. Let's check this out. And upper left and down left. Okay, so I have to, because I've wired it in the wrong way on the down right, I have to rewire these. Goes with the green. And so red and green are down left and down right. The black goes with the green. Black and green are upper left and down left. Okay, so we could say, to make things easier, that if you choose black being the minus, you go the upper with the up and the downside with the downside, and then you have to for the plus side you have to match the left with the left and the right with the right. Let's try this, and we will see if we will be left with the working combined load sensor in a whetstone's configuration. Okay. check this out. And so the remaining one will be the radius. Upper right and down right. This will be the last screw. Hoping it will catch good. And okay. And now the big test. Okay. Okay. I have to rewire the scale to the board. Okay. What you can call? Are you coming out? Ah, senor. Show the Blastic Scale in the basic configuration that works. Even works. It's like a sensible one. You can go up and try to weight a little more heavy object. Right now it is on the little weight side because we are like 0.06. Let's place weight on it. Mi piace l'inglese, Nina. Higher weight can be this one. Okay, and it's really working. It's going to 5 kilos. 7 6 how much I can put on it. It's really working good and nice. I have not to do a little calibration, but so you've finished building your board and modding the scale, and they are connected now. This is the cable. One last thing you have to do is to calibrate it because of the difference between sensors. To get accurate measurements, we have to do this routine using computer. So, using the same USB-C used to power the board, we are going to connect to the computer and execute this rather simple routine, but you have to have the right tools. This was code. Now I am powering the board on the computer. She's starting up, and I'm on the board. I already have my VS Code opened, and I can simply open the monitor here and command directly the calibration. So I will write scale, calibrate, then write the number of the kilo I want to weight. In this example I'm going for 1 kilo. You have to use a known weight. Easily obtainable here is like pasta. So 2 packs are 1 kilo. And as you can see, this is already calibrated. I'm gonna recalibrate it, and let's go. Now it is calibrated. I have to save these settings. and I write EEPROM save, and now it is saved. I just want to okay, I can also do a reset, but it's also already calibrated and it is working. I know this one is 3 kilos 60 and it's not really accurate. That's because by like 2 hectogram. That's because of the nature of the sensor. They are cheap sensors and they are intended for weighting people. So calibrating using 1 kilo of pasta with these is not the best use of the sensor of the scale. So we're going to to calibrate with something that is heavier. I have now this one that is, I know it is 3 kilos and 66. If you have something in the range of 5-10 kilos would be also better. And I'm gonna recalibrate with this kind of calibrate 3.66, and now EEPROM save. Now the scale is calibrated right and it's more accurate. Still retains the weighting of the kilo, and that's the method to get your economical but precise and most of all IoT scale working. If I want, imagine this is plastic, I can upload the weighting. This is let's say HDPE. I want to upload. Now I have not calibrated the Wi-Fi, and so it gives me Wi-Fi error. Otherwise the weight would have been sent online and also stored on a SD card. This is a redundant system and give you some choices. You can also calibrate by SD, but that's some kind of advanced usage that will be explained in future videos. For now, bye.